So first thing I will introduce about the pneumatic and hydraulic system. So for hydraulic is a type of fluid mechanic which is focused on the mechanical characteristic and application of fluid. Hydraulic technology, categorized as hydraulic gearbox and control technology, is widely used in the mechanical and electromechanical sector. A hydraulic gearbox uses liquid as a working medium to transfer power by using the pressure energy of the liquid. The control signal for hydraulic control is a liquid at a certain pressure. Pneumatic is related to fluid mechanics like hydraulic but concentrate on the mechanical properties and application of gases. Similarly, pneumatic is an engineering technology that employs the compressibility of air as a power source and working medium for transmitting energy or signal. It involves the use of compressed air and compressor, valve, actuator, and other components to convert mechanical energy into pneumatic power, which is then used to perform work. So next, I will continue with principle of hydraulic and pneumatic system. For hydraulic, we have three type of principle. Number one is Pascal principle and hydraulic transmission. The most basic theory of the hydraulic system is the Pascal principle. In a closed container, the fluid pressure is equal at point and the direction is perpendicular to the surface. Okay, second is Bernoulli principle. Okay, Bernoulli principle is the pressure, velocity and elevation of the fluid flowing system. Third is conservation of energy. Hydraulic system to the principle of energy conservation. Energy cannot be created or destroyed by can only be converted from one form to other. Okay, the next is pneumatic. Pneumatic number one is Pascal law. When pressure is applied to a fluid in a confined space, the pressure is transmitted uniformly in a direction. Okay, second is Boyle's law. Boyle's law relates the volume of a gas at a constant temperature. It states that the pressure of a gas is inversely to its volume when the temperature remains constant. Okay, third is Bernoulli principle. State that as the speed of a fluid increase, its pressure decrease. The principle explain the airflow and pressure difference in the pneumatic system. It relevant in an application involving fluid flow such as air velocity control and the operation of pneumatic nozzle. The next is component basics on hydraulic and pneumatic. So basically, hydraulic have hydraulic pump, actuator, and control valve, tank, and last is hydraulic accessories. Like a figure 1, as you can see, they have a hydraulic system component, and the next is pneumatic. They have compressor, air receiver, filter, regulator, control valve, actuator, turbine and fittings, pressure gauge, and as you can see at figure 2, main component of pneumatic system.
I'm going to present about advantages of both hydraulic systems and pneumatic system. First of all, hydraulic system has a smaller size with a larger output, which it can be as high as 500 kg per centimeter cube. There is no danger of overloading the hydraulic system. When the pressure exceeds the set pressure, the valve opens and the hydraulic oil flows to the tank through the pressure relief valve. And the third one is output adjustment is simple, where if the set pressure of the pressure control valve can be easily achieved. And the next one is the speed adjustment is easy. If the set flow rate of the pressure control valve is adjusted, it can be easily achieved and stepless speed change is possible. And the next one is smooth movement and easy reversal. Because it has a smaller inertia and it make the movement smooth and the reversal is easy. The next one is hydraulic system is easy to operate because hydraulic equipment is equipped with solenoid valve, electrical components, sensors, programmable controllers, and microprocessors, which can be assembled into various automatic machines. And it also has a high durability because most of the components in hydraulic system are equipped with almost immersed in hydraulic oil, and the most of the hydraulic oil contains a rust inhibitor where it can resist the rust, and where resistance is good and the durability of equipment is high. For advantages of pneumatic system, first of all, it have safety, which pneumatic systems are safe to use as they operate with compressed air rather than electricity. The next one, it is cost effective because pneumatic systems are generally more cost effective compared to hydraulic or electric systems. The third one, advantages of pneumatic system, it has a simple and compact design. Basically, pneumatic systems have a simpler design with fewer components compared to hydraulic or electric systems, and this simplicity translates into easier installation, troubleshooting, and maintenance. The last one is high speed and acceleration, which is advantageous for pneumatic system because pneumatic systems offer a fast response time, which allowing for quick actuation and high speed operations. Next, I'm going to talk about a comparative analysis between hydraulic systems and pneumatic systems. There are 6 properties that have been included, which is first, working fluids. In hydraulic system, it uses incompressible fluids such as oil or hydraulic fluid, which can transmit steady stress and not impacted by the compressibility. In other hand, pneumatic system use compressible gas such as air as a working fluids, where this is to result in immediate reaction and high speed operation. The next one is power transmission. For hydraulic system, it uses compressible fluids in hydraulics to allow it to transmit large amount of force with efficient. Whereas for pneumatic, it is not generating as high forces as hydraulic systems because it provides fast response time to make it suitable for applications such as robotics and assembly lines. Next one is energy storage. For hydraulic system, the power is derived directly from external power source. And for the pneumatic system, the air is being compressed and stored in a reservoir to allow temporary energy storage and release.
For the automotive industry, Perdua Company use this system for engine assembly, chassis fabrication, body panel manufacturing, and suspension component production. In car factories, hydraulic systems are commonly used in the various applications, including clamping and drilling operation. This system utilizes fluid power to generate force to control the movement of mechanical components. Here are description of how hydraulic systems are employed in car factory for the clamping and drilling process. For the clamping process, this system typically consists of hydraulic cylinder, valves, and pump. The clamping process involves the following steps. First, positioning the workpiece, the car part or component that needs to be clamped, positioned in the desired location. Second, engage the hydraulic system. The hydraulic system is activated by pressuring the fluid, which extends the piston or plunger. Number 3, clamping force application. As the hydraulic system extends, it exerts the considerable force on clamping mechanisms such as fixture or clamp security workpiece firmly in place. And for pressure control, hydraulic valves regulate the pressure within the system, allowing precise adjustment of the clamping force as needed. Second, for drilling workpiece positioning, the component to be drilled is properly positioned on a fixture or workable. Second, drilling engagement. The hydraulic system activates a drilling machine by powering the specific rotation and controlling the feed mechanism. Number 3, drilling operation. As the drill rotates, it contains the workpiece and creates a hole. The hydraulic system controls the speed and pressure the drifting process. Number 4, movement workpiece. In some cases, hydraulic systems are also utilized for automated workpiece movement, allowing precise positioning of the component for subsequent drilling operation. For the case study 2, pneumatic conveyor system and material handling. RW company used to handling powders, granules and other bulk material. In food and beverage factories, pneumatic conveyor systems are commonly employed for material handling application. This system utilizes compressed air or gas transport to wide range of materials such as powder, granules and pellets through pipeline. Here are descriptions how pneumatic conveyor systems are used in food and beverage factories for material handling. Ingredient transfer. Pressure conveyor systems are utilized for transferring various food ingredients for storage, silos or containers to the lines. The process involves the following steps. First, material loading. The ingredients are loaded into feeding hopper or collection point which is connected to pneumatic conveyor system. Second, air gas injection. Compressed air or gas introduced into the system, creating high velocity airflow. Number 3, pipeline transportation. The ingredients are conveyed through the pipeline, typically made the smooth tubes using the force generated by the airflow.
This is an example diagram saying that is used in RW. The double acting cylinder shown below is used to generate an oscillating movement in order to provide a bed timely movement. The double acting cylinder also connected to 5-way valve with solenoid. This is the electric circuit. Electric circuit, we have detect switch, switch, relay, and solenoid. When we start the simulation, the circuit will not run automatically, but when we press the detect switch, the circuit will run as it should. Here are the advantages. First one is versatility. The reason is pneumatic system can transport a wide range of material, including powder, granule, and bulk solid through a pipeline or tubes. And next is efficiency and speed. Pneumatic conveying system offer high-speed transportation of material, enabling rapid transfer and continuous flow in manufacturing process. And the next is flexible routing. Pneumatic conveying system enable flexible material flow routing and optimizing manufacturing setup. And next is dust-free operation. For dust-free operation, pneumatic system can maintain a closed and controlled environment during material handling, reducing dust emission and ensuring a cleaner and safer working environment. And lastly is reduce manual handling. Pneumatic conveying system automate material transportation, reducing manual handling and worker strain.